Okay, this is question 9 from January 2022, P3 paper. As you can see, it's trigonometry. It looks like it's a trig equation and then a trig proof, proving trig identity. So let's jump in and get started. Before we do that, just looking at the question, a couple of things that come to mind. First of all, when I'm doing my equation, there'll be a limited number of solutions because x is between 0 and pi. That immediately makes me remember, change calculator into radians. You've got to be aware of doing that. Let's get started then. So 9 part 1 says solve the equation 2 sec squared x minus 3 tan x is equal to 2. Right, so I always tell my students, the more effort you put into learning these trig identities, the bigger the payout with them. As an absolute minimum, I would expect you to know that sec squared and tan are connected by tan squared sec squared. Try and remember all the different things. Cot and cosec are connected by squareds as well. Sine squared plus cos squared is equal to 1. There's as a minimum, you need to know that sort of stuff, which will give you the start off point to one of these questions. So here, when I'm looking at this is a pretty standard one. Not anything too complicated with this first bit. I'm going to simply change this and have this in terms of tan squareds. Then I'll have a quadratic in tan, which I'll hopefully be able to factorize. If not, I'll use a formula on it, but I'll get a solution to the equation that way. Okay, so if we're doing that, know my game plan then. Sec squared is actually 1 plus tan squared x. So I end up with that as my first line. Multiply it all out, so 2 plus 2 tan squared x minus 3 tan x equals 2. Oh, that's handy. They're going to cancel straight away there. So I've now got 2 tan squared x minus 3 tan x equals 0. So I can factorize this, even if it's not a quadratic factorization of, the two brackets that we normally think about. Actually, tan x can come out to give me 2 tan x minus 3 equals 0. So that's a really, really quick one. I'm going to get tan x equals 0, or I'm going to get 2 tan x minus 3 equals 0. So when I'm working these out, if tan x equals 0, then x works out to be equal to pi. And if tan x, which I haven't quite finished, tan x equals 3 over 2, then x is going to work out to be equal to 0.983. Now, whether you do these using the cast diagram, whether you use the graph of tan x to be able to do it, either way we can see that between 0 and pi, between 0 and 180, there's only one value that gives us x equals pi, only one value that gives us x equals 0.983. So that's actually my solution for this one, is x equals 0.983 and pi. That's the first part done relatively straightforwardly. On to the second part, and it says, can we do this proof? We've got that sine 3 theta divided by sine theta minus cos 3 theta divided by cos theta is equal to 2. So when we're doing these, what we would do is start off with the left-hand side and make it equal to the right-hand side, or start off with the right-hand side and make it equal to the left-hand side. I'm clearly going to start with the left-hand side here. And we should, again, if you've learnt some of these formulae, then there's a formula for sine 3 theta and there's a formula for cos 3 theta, or identity rather. Sine 3 theta is 3 sine theta minus 4 sine cubed, and cos 3 theta is 4 cos cubed minus 3 cos. In other questions, we might actually have been asked to prove that. It comes from sine of A plus B, where you have A and B being A and 2A, and we can do it like that, or theta and 2 theta. But no, not with this question. So coming to my proof, left-hand side carried on is going to give me 3 sine theta minus 4 sine cubed theta, all divided by sine theta minus 4 cos cubed theta minus 3 cos theta, all divided by cos theta, and then divide it out. I'm going to get the sines cancelling. I'll get 3 minus 4 sine squared theta. And being careful here, we always have this with a minus and a minus in here. I'm going to get minus 4 cos squared theta, but I'm going to get plus 3 there when I'm looking at that part. So tidying that up a little bit further, I can see I've got 6 minus 4 and then sine squared theta plus cos squared theta. Now, if I needed to show you what sine squared theta plus cos squared theta, you wouldn't have understood the rest of this question anyway. This is an absolute staple that you must remember at all times. And you must, I'm not even going to take too long over this, you must be looking out for, oh look, minus 4 can come out, which leaves me sine squared plus cos squared. Because sine squared plus cos squared is equal to 1. So I get 6 minus 4 equals 2, which is then equal to the right-hand side. Okay, hopefully that makes sense.